Welcome to the basic Python course and its first session, the introduction to Python. So today we will have our first dive into the programming language Python, and we will also write our very first few programs in Python. So in the beginning of this course, I usually make a few organizational remarks. I don't have to do this right now, as this is just the online recording of the lecture. But there are two exceptions. So the first exception is that it's regarding the course materials. So for those who are taking this as a presence course, all the course materials are available on the associated Moodle page. The link you have probably already received. And then the course is also available as an online book, so it can be read on a web page. Because when I was offered this course, I decided that this is very, very good course material, and it would just be a waste of time to create new course material. So all the credits for the lecture notes go to Luke Touch, and I will also provide links to those lecture notes below the videos. This is the schedule for our course. So the course in total consists of 14 sessions or lectures, and the first 9 of those are on basic Python programming techniques. This is here indicated in blue. And the last 5 sessions will be about advanced topics such as array computing, so working with matrices and vectors, data analysis and visualization, image processing, and stimulus presentation in CyclePy. Okay, so the second exception of what I need to talk here in the online recording is the software. So when you are following this course, I recommend to work with Anaconda. Anaconda is bringing you Python in its most recent version, which when I looked it up was 3.9, plus Spider, which is an integrated development environment or IDE that allows you to very comfortably work with Python, plus some other packages that are pre-installed and which you can readily use without having to download and install them. There are instructions to install Python, Spider, or Anaconda, including Python and Spider, on the online course book. So this is the repository that I was talking about, created by Luke. And here you can click on Setup to learn how to set up Python for a range of different operating systems. And if you haven't done so, you should probably do right now, or you should briefly pause the video and install the software, because the coding will start in a few minutes. Okay, before we do that, I want to have briefly make some introductory programs on computer programs in general. And I want to start with the question, what is a computer program in general? If you're thinking about the answer to this question, you're probably thinking of computer program being some kind of algorithm, processing procedure, which takes a designated input, processes it in some maybe mathematical way, and then produces some designated output. So this is using the input processing output concept as a definition for a computer program. In this course, I don't want to work with a precise definition of a computer program, but I rather want to suggest a metaphor of a computer program to you. And this is seeing computer programs as a cooking recipe. So as you know, a cooking recipe always consists of a list of ingredients and a set of instructions. And in principle, it is guaranteed that if you follow these instructions exactly, you are allowed to, and if you use the same ingredients, you're allowed to come up with exactly the meal or dish or whatever as it was intended by the author of the cooking recipe. So in a cooking recipe, the set of instructions is usually worked off step by step, exactly in the order in which they are written down. And this is what a computer program is also doing. We are giving some instructions to the computer written in Python languages. These instructions are called commands, and the computer is working off those instructions step by step. Another important distinction that we need to discuss is the distinction between compiling versus interpreting a computer program. So computer programs, on the one hand, can be compiled, which means that the human readable code, which we are writing, is transformed into machine readable code such that the program is executable by computers. Yeah? In the sense that the machine language is closer to the internal architecture of the computer and therefore understandable and executable by the computer. In order to do this, you need a compiler, and the compiler will generate you a standalone executable of the program. So most of the apps that you have on your computer or also your phone are probably compiled versions or standalone executables of computer programs. In contrast to that, when we are interpreting a program, we are not producing a standalone executable, but we are taking the code, reading it, and work it off line by line. Each line is executed one after another. To do this, you need an interpreter. And it turns out that Python is mostly an interpreted language. And this brings me to the next topic, namely that the interpreter that we'll be using to work with Python. So as I said, the course is working with the Spider IDE, which is included in Anaconda. This is how the Spider IDE looks like after it has been installed. So this is, I think, the default arrangement of the windows here in the Spider IDE. You can also change this by clicking on View and then Window Layouts. Maybe try out other layouts that better suit your needs. So on the left, we have an editor. This is a place where we will be writing our computer programs. This is a bit like other editors you know, such as the Notepad on Windows, but it has more features. And then on the right, bottom right, we have the console where we can run, try, test out Python commands and see their results. And in the console, we'll also see the results of our computer programs written in the editor. And in the top right, we will have a help section. I will say something about the top right later on. Okay, so before we go on working in Spider, I want to just go into the Explorer and open an ordinary editor on my computer. So on Windows, this is called the Notepad. On others, it might be called editor. And please, for this exercise, don't use some word processing software like Microsoft Word, which allows for formatting, because we want to make the point that computer programs are just plain text. Yeah? So this is just for demonstrational purposes. I'm here writing now our first single command program. And our single command program will consist of the following command: print, then we open a bracket, single quotation mark, hello, quotation mark, and closing parenthesis. So I will save this. Under the name Hello World, dot py. So a text editor is typically offering you to save files as text documents with the file extension .txt. And I want you to save this file now with the ending .py. This indicates that it is a Python program. And with this, it can be opened in the Spider editor and run as a Python program. Okay, so now I'm switching to the Spider IDE. And here click Open. And there I have the program that I've just written. And as you can see, it's a plain text file, so it does not contain more or less than what I have typed into the editor. Nothing else. This is just to emphasize the point that computer programs do not contain anything else than the text that you have written into them when coding them. Okay, there are two ways to run a computer program in Spider. One is just to click on the green triangle above the editor. The other is to press F5, and this is what I will do now. And if I do this, I see some output on the console. So first, I see that by pressing F5, I've generated the command run file and then pass the file name of the program that I've written. And this produces some output, namely the output hello. Okay, so it is important to distinguish between the contents of a text file and the effects of the computer program. Yeah, this is our text file. It consists of a single line, which is a Python command. When we run it, we don't see the contents of this text file on the console, but we here see the effects of our commands, which in this case is printing the word hello to the screen. Okay, so let's have a closer look at our first program. Basically, it consists of three parts. First, there is the word print. Print in Python is a built-in function, and all it does is basically writing something to the screen. Then we have parentheses or round brackets, which indicate that the built-in function print takes an input argument. So we need to give it something in order for it to do something. And third, there is the word hello included in single quotation marks. These single quotation marks indicate that we want to use the word hello as is. Yeah, so it should be displayed exactly as we write it. And this indicates that we don't, for example, use it to refer to a variable name, which we will see later. The rules which govern the language Python and which determine whether commands are correct or incorrect are called the syntax of Python. And if you're violating these rules, this is called a syntax error. So in this example, we would be committing a syntax error if we were to remove the single quotation marks around the word hello. So if I now save the program and run it, I'm getting a syntax error and it's saying invalid syntax. Why? Because this is not a well-formed command. Python doesn't understand what to do with it because it's believing that hello refers to a variable and then the dot doesn't make sense. Okay, so I'm going to change that back and save it again. So with that, I want to open our second program, which is called greeting.py. Okay, so what are the ingredients of this program? We see that it is a longer program than the single line program that we've written before. And it also has the command print hello in it, but there's more to this program than to the one before. First, there's something here at the top where we have a text enclosed in triple quotation marks. This is called the docstring of a program. The docstring of a program is used for documenting the program. So you should, in a docstring, you can, for example, write down who has written the program, when it was written, maybe contact details of the person who has written it, email address, and most importantly, the purpose of the program, briefly describing the purpose of the program so that a reader of the code immediately knows what it's generally about. Doesn't need to be very long because you will typically write more comments than just the docstring into your code. This is shown here on lines 6 and 8. So as soon as you write the hashtag symbol, everything that follows the hashtag symbol on this line will be ignored by the Python interpreter. So it will not be considered Python command and will not be attempted to run. This is very useful for writing comments into your code. Yeah? So here above the print command, we were, for example, writing a comment. This is the command that prints out the message. And then there is another comment 2 lines above, which says that we want later do another task, namely to personalize the program by getting the user's name before. Okay, so whenever you're writing a program, the cosmetics of your program and commenting are important. You cannot write too many comments. You can just write too few programs. Writing comments is important so that other readers of your code understand what you're doing. And it's also important for the future you. Yeah? So if you are returning to this code like 10 months later or 10 years later, might be helpful to have a comment explaining what exactly the commands were intended to do. Okay, so with that, we can also run this program. And as most of this program are the docstring and comments, it basically does nothing else than the program before, just printing out the word hello. Okay, so with that, I want to open the third and last program for today. It is called Greeting Personal, which actually solves the to-do mentioned in the previous program. Okay, so if you're feeling adventurous or have fun in making predictions, you can now pause the video and try to think about what the program will do before we go on. Okay, so I'm running the program and we see that this time the program asks us for some input. Yeah? So you see the blinking cursor here where now I can enter something. Before I do this, I want to demonstrate you how to stop a program in case it's not stopping on its own, as in this case. So for doing this, you can either hit the red square here in the console. This will stop the program. And equivalently, you can also press Control C. So I'm pressing Control C now, and this aborts the program. So whenever you are in the process of testing a program and you don't want to work through it until the end, just press Control C, and this will stop the program. I'm now gonna start the program again and will properly use it. That is, I'm entering my name. Okay, so by now we have probably understood very well what the program is doing. So here it's using input, which is another built-in function on Python. And the input argument of the input function is the prompt that is to be displayed on the console before the user input is queried. And after this has been done, the program waits indefinitely until the user has been making an input, which is confirmed with return by hitting the enter key. The output of this input function, that is the text that the user has entered into the prompt, is then returned and saved into a variable called name. On the next relevant line, which is here line 13, this name is then combined with the word hello to create a message. So hello is a sequence of characters, and name is another sequence of characters. So both are words. And the plus sign allows us to combine words into combinations of words. Yeah. So that's basically just concatenating these sequences of characters to have another larger sequence of characters. In other words, the message then after that is just hello Johansson. And then on the last line, the message is being printed using the print function that we already know. But observe that this time we are not having quotation marks here. We're not writing quotation mark message, quotation mark, indicating that this time we are not referring to the sequence of characters as we have inserted it, but we are referring to the variable message that we have created before. And then this variable is taken and its contents are being printed to the console, which is exactly what was happening here. Okay, so it is important to understand that variable assignments or commands in Python are not mathematical equations. Yeah. So this does not say the name is equal to whatever input, what is your name gives me. This is not saying that message is equal to hello plus name. This, for example, becomes evident when we try to switch sides, which we can do in mathematical equations, but which will give us an error right here, because we can't assign value to a function call. So variable assignments in programming languages are not to be understood as mathematical equations, but they are rather to be understood in the following way. Take whatever you find on the right-hand side of the equation sign, work it out, perform the necessary operations, and then store the value under the variable name, which is on the left-hand side of the equation. Okay, the next point is that in programming, obviously, order is important. So we cannot refer to variables if they have not been created already. If I, for example, would move this line, print message, up here, I would get an error because the name message is not defined, and therefore, intuitively, it cannot be used as an input to the print function. I'm gonna revert this. Then the next point, which is important, is that variable names are arbitrary. So it's clear that with this input, we are querying the name of a user. But in our program, we don't need to call this variable name. We can also just call it X, provided that later on, we then always refer to it as X. Yeah. So if we are running this program in this way, it's also working fine. However, there are restrictions for variable names. So variable names can include numbers. I can, for example, call this name1, but they should not start with numbers. So for example, the variable name one name would be prohibited. Yeah? This is invalid syntax in Python. Similarly, one should not use spaces in variable names, and by the way, also not in file names. So if I here replace name by my name, the program is also not working. It's also not invalid syntax. Python doesn't know that these two words belong together and are supposed to be one variable name, but it considers this to be the names of two variables, which then gives an error because this is not a well-formed command in Python. If you want to use separate words as variable names or file names for scripts, better use the underscore. So you can see that this has also been done in the file name for this program. It's called greeting underscore personal. Similarly, we could work with the variable name my underscore name. So in this case, it's also work. I'm going to revert this again. Finally, variables should not be named after functions. So if you, for example, replace name by print, that's not going to work well because we have then overwritten the built-in print function by our own variable name, and we get a type error in the last line of the program. I'm going to revert this. Okay, finally, I want to emphasize this distinction once more between sequences of characters and variable names. So as I've told you, the plus sign allows to concatenate sequences of characters or strings, as they are also called in programming. So if we would put the name here in quotation mark, this command wouldn't concatenate the word hello with our name, but it would concatenate the word hello with the word or the noun name. So it would basically ignore the name that we have inputted. Run this program once again. So in this case, the output would be hello name. This is type of programming error which can be very annoying because it doesn't give an error message. The program runs without problems, but obviously it's semantically not correct because what we want here, the message to be is hello and then the name of the person and not hello, the word name. The same problem would occur if we put the word message here in quotation marks. Yeah. If we do that, we're not printing the contents of the variable message, but we are printing the word message because we have used single quotation marks here to indicate that we want this to be considered as is. So in this case, our name would not be ignored and combined into the message, but the message would be ignored, and instead we would print the word message. Yeah. So keep in mind this distinction between sequences of characters as indicated by quotation marks and variable names, which should not be enclosed into quotation marks. Okay, so this is all for today about our first programs in Python. To finish, I just want to now introduce you a bit more to this Spider IDE again. So one point that I want to make clear is that there's absolutely no distinction between running a program from the editor and typing all those commands into the console. Yeah. So I could, for example, copy all those commands to the console and get the same, sorry, and get the same output that the program is giving me. However, with longer programs, this starts to become tedious because we would need to copy a very large number of commands to the console, and it's much more comfortable to run these programs from the editor uh, as we were also doing now. So in the course of this program, I will often work in the console to demonstrate things or to try out things or to see what certain operations are giving me. However, when you are programming, when you are solving the exercises, when you're submitting the homework, do not just do this on the console, but always write entire computer programs, save them as .py files, Python script files, and send them to others if you need. So to sum up, the editor is the place for writing a computer program. The console is the place for testing commands and debugging your program. On the console, you can also use the up key. So I'm now pressing arrow up to access previous commands that you have entered into the console. This is very comfortable if you, for example, want to search through all the previous commands that started with the words PR. And this will give you all the print commands that you have previously entered, for example. You can also see all the programs that you have previously entered in the console in the history tab here in the bottom right. So this is a list of all the commands that were previously entered into the console. When you're on the console, you can also write %clear or press Control L to clear the command window. Yeah. So this doesn't affect any Python programs in any way, but if you are tidy-minded and want to have a fresh start when starting on a new section or topic, you can just type the %clear to clear the console. You can also type %reset to clear all the variables from the workspace. But before I do that, I want to show you the variable explorer. So when we have typed something into the console, or when we were running a computer program, all the variables that were created during the course of this computer program are in the main workspace. And the contents of the main workspace can be seen by clicking here on the variable explorer in the top right. So in this case, we have two variables there, which are both strings, namely the variable name, which is my name, and the message. If you then on the console type %reset and hit Y for yes, then the workspace is being deleted and your variable explorer is empty. Okay, so as I said, this would be it for today. One general recommendation when you go on. If you are working on computer programs, do not just stay in the editor, but um, always take your commands to the console, vary them a bit, make some predictions about what's going to happen, and then see whether you were correct in your predictions. This is a very good way of learning to code. Always modify your commands to see how this changes the output that you get. Finally, you can also go to the lecture notes. So this would be the lecture notes from today's session. It contains everything that we talked about today. And in the very bottom, right before the exercises, there's also a link to some example programs which will occur in the course of this seminar. So you can already download these to your computer to have them available. Okay. Finally, there are exercises below each session's lecture notes. So if you want to test your knowledge, try these exercises. And if you're taking the presence course, please also send them to me. Okay. So this was it with session 1 of the basic Python course. I want to say goodbye and hope you also enjoy the other videos. Bye bye.